Week 20. Last week was quite a bit of a flop. As soon as my friends left, I became just incredibly ill. I don't remember being this sick for a long, long time. I ran a moderate fever. For me, it was pretty high. And I don't remember the last time I had a fever. I had massive headache and just fatigue, and I couldn't really do much of anything. I was supposed to implement RevenueCat's functions in my view models so that my UI would actually talk to the SDK in the backend to, make RevenueCat work. Just for context, RevenueCat has already been implemented in my data layer, and I just actually need to make it work in the view models. So it should have been an easy thing to do. But I spent about half a day to about a day looking at trying to get it to work, but I didn't manage before I ran out of time. I have to record this video. I think I know what the problem is. I just need more time to dive into the issue. In this video, I want to briefly talk about the issue, but before I can get there, I think it's important for me to paint a little bit of a background with regards to the tech stack I'm using. I'm writing an app, right? And it's supposed to be deployed on Android and iOS at the very least. And I have dreams and hopes about putting it on desktop and eventually on web. So with my previous Android development experience, I chose Kotlin multi-platform to deploy this particular app. And it wasn't long ago, probably, like in the last decade or so, when you wanted to deploy an app to, let's say, both Android and iOS, you'd have to write the same app twice, once for Android in Java and now Kotlin, and once in C# and now Swift for iOS. So imagine if you're a solo developer and if you have a company and you want to, make an app for both platforms, you'd have to essentially manage two different teams, and just two of the same things can get quite tedious, and it literally have your sort of output, right? And obviously this was a problem, and people came up with solutions. For the longest time, the solution was using something called React Native or something similar to that, like Angular. I think it's another popular one from Google. The idea is very similar to Java. If you remember in the olden days, if you wanted to write an application for Windows, Linux, and Mac OS, if you don't want to write multiple times, you would write it in Java, this language. And then you deploy it to a Java virtual machine that runs on top of different operating systems, so that you write the application once in Java, and then you deploy everywhere, right? That's Java's dream and goal. And to be fair, it accomplished that mostly. And this is sort of the layered translated approach, because you write in Java, and Java then speaks to the Java virtual machine, and then the Java virtual machine then speaks to your operating system. Then your operating system then speaks to the underlying hardware to make everything work, make your computer tick. And this particular approach has a big problem, as you can see. It's performance. If you remember the early days of Java, one of the biggest issues that people ran into was actually the translation layer costing a lot of performance cycles. And React Native has a little bit of that problem, but obviously nowadays the modern implementation can be a lot smarter. But there's still this sort of nagging feeling that, hey, well, I'm still not deploying native code, and perhaps we could do better. And Kotlin multi-platform is something that aims to solve that. It tries to run as much native code as possible in different platforms, on different platforms for mobile, for Android and iOS. So the idea is that you write in Kotlin, and then you deploy to both iOS and Android and desktop, and ideally at some point web. So this is the tech stack, the framework I'm using. This sounds very sort of appealing, and it is. I mean, don't get me wrong. Like I don't have to deal with a lot of Swift code. I don't really know Swift, and I don't really want to pick that language up if I don't have to. So Kotlin multi-platform has enabled me to actually do this on two or more different platforms. Problem is, different operating systems still do different things very differently. So there's only so much Kotlin multi-platform can manage. And for the most part, it does a very good job. It sort of abstracts away the differences so that you don't have to directly deal with them until you run into the platform-specific requirements. RevenueCat, keep in mind, deals with in-app purchases. And in-app purchases, obviously, on Android, it's on Google Play Store, and on iOS, it's on the App Store. Obviously, they interact with very different backends, and they have very different policies. And as a result, the endpoints, the SDKs, the functions that you have to call in iOS are very different than the functions that you call in Android to make in-app purchases work. RevenueCat, the Kotlin multi-platform component of RevenueCat, deals with this issue in two separate steps. So number one, in the RevenueCat initialization, so when your app first starts and your app needs to initialize an instance of RevenueCat so that it can interact with the SDK, so the SDK can be initialized to interact with the backend API, this is done platform specific. So in Kotlin multi-platform, you would use the expect actual paradigm, and which means that once you declare this in the common code, you'd have to write platform specific implementation in both Android and iOS, right? So I understood that part, and that's what I needed to do to put the RevenueCat's SDK into my data layer. However, last week when I was trying to do the actual calling of the functions, I first, for whatever reason, my brain was stuck in the same mode. I thought that I needed to do the expect actual situation until I realized a bit too late that RevenueCat actually abstracts that away from you. You can actually use Kotlin multi-platform in your common code and just write once, and RevenueCat knows what to do on both platforms, so long as the initialization code, initialization declaration was done correctly with the expect actual. So I think that was the problem I ran into, which means to fix it, I just need to actually, guess what? Actually follow the documentation and, do the Kotlin multi-platform implementation for the actual calling of the paywall. So that's the problem I ran into. And so that's the goal for next week. And I need to start to sort of accelerate a bit of my pace because I'm running down to about three or so weeks before the deadline I've committed to myself for the very first alpha release on Android for our testers. So next week, the goal is to get this to work and then start doing integration testing. And I know I will run into many issues. And the goal is to start at least a process to sort of get a sense of how big the scope is and then start addressing those problems before I can have at least a half polished product by the end of the first half of 2025. So that's it. That's the situation. So last week, not much was done. I was supposed to put the RevenueCat functions into the view models to make it work. Didn't manage to make it work, but I think I know what to do to make it work, which will be the focus next week. In addition to this next week, I will also start integration testing and start tackling issues that are found in integration testing and hopefully come up with an estimate in terms of how big the problem scope is for the app, for the alpha version of the app. That's it. I'll see you next week. And I hope I won't get sick again.